Let me ask you quickly. So, how many types of routings available?
Dynamic and static routing.
Dynamic and static. And what about the default?
And default route, yeah, and default three types.
Three, right? So, when the default route used?
For unknown destinations, internet.
Exactly. And static?
Static used for small networks.
Okay. And okay. And what about dynamic?
Dynamic is the one who most common use was is build up the routing table when you configure
Okay.
the neighbor.
So,
It
what is
is
the
connection to WAN network. Dynamic.
okay? So, what's the difference you have seen in static and dynamic? See, these are the interview question, guys. Actually, what difference you notice between static and dynamic routing?
Static is manual configuring.
Exactly, exactly. This is what needed. Dynamic, the protocol does the routing, right?
Yeah.
The protocol itself populate the routings and all. Okay, so in the dynamic routing protocol, sorry, in the dynamic routing, so what are the major categories? Can you tell me first?
RIP version 1,
No, no,
RIP
no, 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 no. The major categories are, we will discuss in the detail. These are the major categories: IGP and EGP,
okay.
interior gateway protocol and exterior gateway protocol. Then again, the this IGP again categorized into what is called distance vector protocol, where RIP come. Then link state protocol. Okay, so this is the second category, and the third one is a hybrid protocol. Okay, so link state protocol. Okay, distance vector protocol. We have discussed about this. So Bellman fold algorithm. It uses this is nothing but RIP. So periodic update. You remember we have seen even yesterday also we tested that again. Like you have one router here, one router here. Okay, so these routers, this it is having one LAN. It is having one LAN. So what will happen when you configure RIP here on this router and on this router? So what will happen? They both will exchange their routing table to each other. So like this guy will know all three routes. This guy will know all three routes. So this network has three routes: one, net two, and three. So yesterday we tested that when this interface, this LAN is down. So this router is coming to know after 4 minutes to 40 seconds. Till that time, this router will be unaware. This router will say, no, no, I think I'm still there. My route is there. So that was the disadvantage we have noticed with that. So and full exchange routing table and all. So link state protocol. Okay, it is the successor of that distance vector protocol. So when distance vector protocol, okay, see whenever I say distance vector protocol, so I will remember that RIP. That is the first protocol which we learn. Okay, so that was having some problems. So now the link state protocol came into picture. So what is this protocol? So this is a Dijkstra algorithm. It uses the Dijkstra algorithm. Link state updates. Okay, link state updates means what? See this. These are the three routers. Let's say this is this router, and this router. Okay. So if I say like this is having LAN, this is having LAN, this is having LAN. So link state update means if like what happened, like we configured when we configured the OSPF on these three routers, so they will become neighbor to each other. They will become neighbors. Yesterday we have seen, today also we'll see, show IP OSPF neighbor. So this router will know about this router and this router. When they become a neighbor, then they will exchange the routing table. Yes, okay guys, you can share with me like this. Okay, so link state update. Link state update means if something went down here in this scenario, we will see the same lab again. We will shut down this and we will see on UK router what will happen. So will it wait for 4 minutes like RIP was waiting? Okay, that we'll see. Then classless routing protocol. It supports subnetting. Like if you use /16, if you use /20, 22, 21, /30, whatever it is. So all the subnetting it support. Missing routes are exchanged. See, if suppose this is network one, this is network two, right? So when India router exchange the routing table, okay, and UK router exchange to this guy, US router. So just they will say, oh, okay, US router, you just don't have this network. So only the missing route will be exchanged, and this will say, oh, you only know about, you don't know about this one. So only the missing routes will exchange. And updates are through multicast. Multicast means what? Multicast means a specific group. Let's say here one more router is here to US router. It is connected like here. So it will see if OSPF is running there. If OSPF is running there and they are neighbor, then only it will pass here. The updates will pass to the OSPF neighbor only. It will not pass here. Why? Because of the multicast. Multicast means it is used for the specific group. It use some special IP address. Okay, what IP address we will see that OSPF. So for advantage of OSPF, much faster to convergence. See, link state protocol is much faster. Okay, if something happened, if some network went down, within fraction of second, within few seconds, you will come to know that okay, this is down, this is up. No routing loop. See, router know everything, because you know why? Because here in the router you make a database itself. So we will see that if you put show IP OSPF database, so you will see the router make a database, okay, and force you to design your network correctly. So in the link state protocol, the design should be very correct. Okay, and disadvantage. There are some disadvantage of link state. What is that? The demand on router resource. See here in the OSPF, what will happen? The router maintain three tables. One is a neighbor table, second is a database table, and third is a routing table. Okay, and apart from this, they will maintain like in every few seconds they will send a trigger update. There will be some LSA packet will be changed between them, and also n number of things. So router will be keep it resources, its hardware will be utilized quickly, immediately. Then required a solid network design. So it required a solid network design. So it is not like RIP or static. We will do within a night. But OSPF, it required a very strong design and all. Okay, and technical complexity. So it has some technical complexity. But OSPF is the king of the protocol. Remember this one, because it is the king in the IGP protocol. Okay. So OSPF. So a few points about OSPF. It is stand for Open Shortest Path First. See, the if you understand and OSPF, how the OSPF works is, see, let's say you have these routers, and they all connected like this. Here, here, here. Okay, this is router one. This is two. this is 3, this is 4, 5. Okay. Now, two. Okay. See this guy. So here you have one network on router 1. He want to reach to the network 4, which is nothing but the router 4. So how many ways it has? Can you answer me? How many path?
Two paths.
Right, two path. The one path is either he can go from 2, 2 to 3, 3 to 4, like this way, and either it will go from 5, 5 to here. So in his database table, he will maintain. Okay, these are the possible things. But in the routing table, he filter only the shortest path. In the shortest path, it will reserve only this part. If you want to go to one router 1 to router 4, right, then go via 5. Okay, but this route, the 2 to 3, 3 to 4, it will be there in its database table. And when that route will be active, when this link went down, if suppose something happened here, so immediately from its database table, it picked there. Oh, I have alternate option. Now here in its routing table, this route will be replaced with this one. Go 2 to 3, 3 to 4. So so the shortest path, shortest means remember this one. So it takes shortest path to reach to the destination. And apart from this, it is very, very faster. So this is a standard protocol. You can run on Juniper OSPF. You can run between Palo Alto Cisco. You can run between Checkpoint Cisco ASA. Anything is possible. It is a link state protocol. It uses shortest path first algorithm. Yeah, unlimited hop count. See, in RIP, see the best thing to run the routing to learn the routing protocol is comparatively study. Okay, after this we will see that comparatively study that you should okay what RIP does and what OSPF does and what EIGRP does. So if you have that table, then it will be very useful. It will be you will remember it very clearly. Oh, okay, this is so these all are the interview related questions. So unlimited hop count. See
It is
RIP.
open source protocol.
Yes, this is a standard or open source. Yeah, you can run that in OS Palo Alto also. You can run it on Checkpoint. Okay, so unlimited hop count. RIP was having limitation of 16 routers only. See, only 16 routers it can handle RIP, but OSPF has no limitation. You can run n number of routers, n number of networks you can add routers. Metric is nothing but the cost. The distance, like okay, this from network 1 to 4, how to go, like what are the ways? 2 2 to 3, 1 to 2, 2 to 3, 3 to 4. This is one way. Then 1 to 5, 5 to 4. So the distance, this is calculated by the cost. That is nothing but the cost. So in this terminology, it is called the metric, and metric is nothing but the cost. So cost is how it calculated, 10 is to 8 divided by bandwidth. So we see the bandwidth of this link, okay, into 10 is to 8. So this is the calculation the protocol does. The OSPF does this on this base of this calculation, based on its metric. It will say it will see the distance. Okay, then administrative distance is 110. Okay, can you answer me? RIP administrative distance was first.
120.
Exactly, 120. And static default?
1 and 0.
Exactly, 1 and 0. It is a classless routing protocol. See, it supports subnetting. Subnetting means, see, generally class C, what we do, it represents /24. So the same class C, you can make a /20. So that is done by the subnetting. It support VLSM and CIDR. VLSM again, it is the subnetting and supernetting. It is called. It support only equal cost load balancing. It support only the equal cost load balancing. Load balancing means see, like mm, to reach one what is called if you want to, if you have a redundant routes to reach one particular destination, so it can balance. Okay, let's say you have two links, this one and this one. So equal cost load balancing, you can utilize this route and this link and this link also. So it happen into the load balance. So it support equal cost load balance. And it introduced the concept of area. This is something new. Area to ease the management. So OSPF started a concept of area. What is area? So area is nothing but it is the boundaries. Okay. So the first thing, every router, your first your network should be into the area zero. Area zero is nothing but the origin of any network. Okay. So and every other area 2, 3, 1, they should be connected to the area 0. So if you see here, area 1, it is connected to area 0 via C. D and E is connected here. And this class A is, sorry, router A and B, they are purely in area 0. Okay. And if you see the class C, it is it's half portion in area 0 and half portion this portion in area 1. Can you see? So this is called ABR. Okay, this is origin router A and B. This is called ABR. So it is participating in both areas. Okay, and this router, which is completely, it's both link. If suppose you have one more link, it will be in area only, area 1 only. So like this it will happen. So if some so this C router, it is responsible, let's say from area A, it is configured here, some more networks are here. Okay, and area this router F, it is again participating in the RIP protocol, let's say here. So in F, two routing protocols are running, RIP and OSPF, because it's this interface, it is participating in OSPF, this interface participating in RIP. So this is called ASBR. The terminology we will see later. Just for introduction, you can see ASBR. This router is participating in both routing. This router is participating in both areas. These routers are solidly here. So this is the OSPF area. So why it is used? Because for the ease management. Okay. So OSPF, it is it use the link states. Okay. So if anything happened to this area, this side, so this C is responsible to update into the backbone, and from here it will know to everyone. So that's the beauty of. So it has the dependency, and it is a centralized management. Okay, we will see that. Digit strap. So the hello packet. What will happen? How the neighborship get formed into the OSPF. So what will happen? So this is two routers, one router and second router. Router 1, router 2. So what you did, you just configure the OSPF. Configure the OSPF and area C. So when you configure, so both router will send hello packet. Hello packet means what are the content in the hello packet? See guys, OSPF, it is a very lengthy protocol. There is a separate books written on the OSPF. So just think about that. How much things there to learn. So but the understanding is important, and in the next level there are a lot many things to learn in the OSPF. So just don't just think that OSPF, okay, just configuring it. Configuration is very easy, but it has many things to do. So router ID. Okay, so what will happen in when this guy, he will send hello packet. Hello, my router ID is this one. I have a hello and dead interval this one. My neighbors are this. My area is this. My router priority is this one. My DR and BDR, and this is the authentication password. It will send to this guy. Similarly, this guy will send hello. These are my details. So based on that, you remember in STP what was happening? Which packet STP switches sent? Can you please tell me fast? In spanning tree, what was the packets? What was the name of that packet? Come on, where the root bridge to elect there was a to elect the election. There was one packet called BPDU. Remember, in the BPDUs, the bridge ID was used to send. So similarly here, they will send each other hello packet. In hello packet, they contain this information. So based on that, router ID, hello interval neighbor. So one guy will become DR, designated router, and one guy will become BDR, border designated backup designated router. Okay, so now this guy will send, okay, I become a DR, you become a BDR based on the election. And the election is again based on there are some calculation based on that. An election will happen, one guy will become DR, one guy become BDR, and finally he will say, okay, now take my route. So he will send route to this guy, and he will say route to this guy. So now they will become neighbor to each other, and they will exchange the routing tables. So this is how the OSPF works. Very short description. But remember, this is not the end of OSPF. It has many things to learn. But to have the base, this information is sufficient. Okay. So, but as I told, we can go into much deeper of the OSPF. So let's do here. Okay. So this is our lab. So let me quickly check. This is India router. Enable. So run. Hmm. So terminal, no OSPF, no router OSPF. Sorry. Yesterday we configured I will configure once again. See, no router OSPF one. So I remove that. Similarly, here, no router OSPF one. No router OSPF. Okay, now. So all the configuration got removed. So now, guys, listen here very carefully. So now this is our base diagram. Again, India router, USA router, UK router. India has this LAN. This is the USA LAN. This is UK LAN. And these are the WAN. So our main objective. What is our objective? Our objective is India machine should reach to this one. But can you see? Currently it is saying destination host unreachable. Why? Who is dropping? How can I check that? Do the trace out. See, the India machine, it is going to its gateway. After that, and where is the code? Gateway? Gateway is here. And after that, it don't have a route. So what's the solution? So we know that static routing. We know the default routing, and we know the RIP. So now let's try OSPF. What to do in the OSPF. See, the first thing, if you see show IP route, can you see you have only, oh, okay, fine. So let me remove this one. Interface. Show IP interface brief. Can you see two interfaces? Show IP route. Can you see two networks? 192.168.1.0, 192.168.10.0. Agree with me? Yes. So you just need to configure router OSPF router. See, when you put a router, just put the question mark. So you have to learn these four protocols: RIP, OSPF, EIGRP, and BGP. So RIP we discussed. You just put the RIP, enter, and put the network. But in OSPF it is a bit different. थोड़ा सा अलग. OSPF, when you say enter, see it said incomplete command. So it requires some more thing. What is that? Process ID. Process ID is nothing but it is a number. So you can run multiple process IDs into one router. So just don't go to complexity. Just make it simple. Process ID I'm taking one. Okay. Now next what? Network. I need to advertise my own network. So in RIP, what we did 192.168.10.0, right? This is our network. If you put this in OSPF, it will say incomplete command. Why? It requires some more thing. What is that? Question mark. It is asking for the wildcard bits, OSPF wildcard bits. You know, wildcard bit is nothing but what is that? Yes, it is here. So see here, it is broadcast subnet minus your class C subnet is equal to wildcast. I'm sorry. Okay, so broadcast. See, broadcast means what? 255, 255, 255, 255. And what is your network subnet mask? So for 192.168.10.0, this is your subnet mask. So you need to minus from that. So what will remain? So 255 becomes 0.0.0.255. So it is nothing but you. In short, the OSP wildcard is nothing but the inverse of your subnet mask. So what is my subnet mask of class C generally? 255.255.255.0, right? So all 255 will become 0 and 0 become 255. That's the your wildcard mask. 0.0.0.255. This is your wildcard mask. Okay. Next, see, still it is not finished. When you put this one, now you need to define this network is belongs to which area. So see, this many area you can create. So we just will make it simple. Area 0. That's it. Similarly, what is my another network directly connected? So I will just go and edit here. One dot. My WAN link. And its subnet mask will 255.255.255.0. So the wildcard mask will become the reverse. And area it is also in area 0. Done. What configuration I have done? Do show history. I just configure router OSPF 1 and configure this two command. Network 10 area 0 and network 1 area 0. That's it. Anything else I have done? Nothing. So now let's go to US router and see here. See, for dynamic routing protocol, whenever you want to configure, just check the route. So IP route direct connected. See, it is showing I have three routes connected to me. 1, 2, and 20. So these all three routes you need to advertise into the OSPF. And you know slash 24 represent it is a belongs to class C, right? So now I need to configure OSPF. Config terminal router OSPF 1, same process ID. Network. What is my LAN? 192.168. 192.168.20.0, right? Wildcat mask 0.0.0.255, area is 0. What is my another WAN link? 2.0. And what is my this side? This side. See, what I did is just see here very carefully. In USA, I first advertise this one, then I advertise this one. So now when I advertise this guy, so what will happen? Remember here, this side, this side is already he is looking for the OSPF. So what will happen? We will see that. So to know that, let me debug. Let me on the debug this side. So debug is something. Debug OSPF. Debug IP OSPF events. Okay. So now see in India router I just put the debug. So let me advertise the route here. 1.0. Just see here what will happen. You will get one message here. One second. So can you see some message came? What does it mean? It means that there is one neighborship get. Okay. So see, if you want to understand the OSPF, on the debug and check. Now we will see here on this router. Can you see how many data came here? See. Okay. So let me turn it off. So how to turn off? Just say undebug all. So let's go and start. What happened? See when we on it. So what happened? So this is the India router. So on India router this time, OSPF receive hello from 192.168.20.1 area 0. So it 192.20.1. Who is the 20.1? It is nothing but the our US router, right? So and it is also say giga. It is coming from Giga Ethernet 1.2, right? Then what it said end of hello processing. So hello process done. Then again what it is say receive DVD from database packets from this guy 20.1 on this sequence something. Then a state is initial state. Okay. Then what happened? Receive after that send. Now this guy sent to 192.168. Okay, and NBR negotiation done. We are slave. See here the election happen. Election happen for who is the master and who is the slave. So based on election, the India router said we are the slave, and that router become that US router become master. Then what happened? Send again DVD. Send receive. Now can you see the states? States are getting changed. Initial state, then master and slave stage, then exhaust exchange state. Okay, then exchange state. And if you come down, exchange done. Can you see here? So exchange done means what? So both routing they exchange their routing table. Exchange is done. So send IQ and send DVD synchronize with this. Can you see the state is full now? State full. And finally, the OSPF adjacency process one neighbor. This guy become neighbor from this. It's coming from here from loading to full, and loading is done. Now, what happen is both become neighbor and they exchange their routes. So so this is nothing but the neighborship process. This is what happened in the background. So Like you can learn more on this one, in theory, and you can understand this one. But this is how the OSPF works. Process ID, TR, okay. Then again, if you want to go again, hello processing, neighbor change, and this one, DBR election, BDR, blah blah blah. So this all thing will happen. See who will become DR. This guy become DR, and this guy become BDR, backup designated route. This guy become designated route. Can you see elect? See, elect. Elect means election. So this guy become, it is elected as a DR. This guy become elected as a BDR, right? End processing and neighbor change event, like this. So this is how the this thing's done. So similarly now, uh, okay, now if you go here in India router and check show IP OSPF neighbor, who is the neighbor? See, this guy become neighbor. 20.1 is nothing but our USA router. So you can change this if you use the loopback, or if you use the router ID, so it will see show the router ID here. Priority is 1, full DR. See, this guy is a DR, state is DR, it is the dead interval is timed, this one. And the address is 192.168.1.2, and it is coming from this interface. So this is the first table. Then if you see here, show IP OSPF database table. See, this is the another table which OSPF use, database. So it will say link ID, router ID, edge, check link, and link router and all. So many things will be there. And the finally the show IP OSPF, show IP route. Okay, this is the third route. See, right now it got two but do you see the 30 here? 192.168.30.0? No. Why? Because we haven't enabled 30 here. So let's see here. See, I'm in India router. Let's see how much time it take when it become neighbor. So let me go and configure here. Configure router. Before that, we need to see show IP route, or you can see this IP interface brief. So just say router OSPF 1 network 192.168.30.0, then wildcard mask 0.0.0.255, then area 0. See, LAN I advertise. Now, can you see now? When I advertise 2, see what will happen. See, within few seconds, got the adjacency information. Process 1, neighbor. You got the new neighbor 192.168.20.1, and he said loading full. And see, now if I see here, show IP route, can you see? Show IP route SPF. Can you see? I got all the routes 3, 20, 10, everything. Can I ping to India router from here? India machine 192.168 10.10? Yes, I can ping. Can I ping to 20.10? Yes, I can ping. See, from router I'm pinging. How simple it is. So, okay, now let's see here. So here, show IP OSPF database. So see, now in its database, it store all the details, history. So there are 3 networks actually in this topology: um, 10.1, 30.1, 20.1. Do you agree with that? Then it has the ages and all these details. Then based on that, show IP OSPF neighbor. So for UK router, this guy is the neighbor. But similarly, if you go for USA router, how many neighbor will be here? Can you tell me first? Show IP OSPF database. Database is same, but show IP OSPF neighbor. Can you see 2 neighbors are here? India and the UK, and their IDs are here. and one is DR, one is a PTR, right? Similarly, show IP route. So O means O represent the OSPF. O represent the OSPF. Okay? So if you see show IP route OSPF, can you see? O. So this is okay. Now, guys, are you with me or everyone's with?
Yes.
Yes.
So let's see.
Yeah.
Let's see one thing. So I'm in the UK router. Okay, I'm in the UK router. So now we know that all the routes. So IP OSPF, so IP route OSPF. So how many routes coming from OSPF? 1, 10, and 20. Okay, so now what I'm doing, I am going to shut down the India LAN interface giga Ethernet 0 by 0. Shut. How much time it take? See, I just shut down. Can you go and check here? Can you see? In few seconds. See, till now it was here, but can you see the 10 dot gone? Now my reachability gone. Do you remember in RIP how much time it takes to remove the routes?
4 minutes, 240
Exactly.
seconds.
So which one is better? Can you tell me?
This one.
Exactly. So now see here. So link state update. See now I'm making it no shutdown. So I'm just going to UK router again. Can you see it came back? So who informed him? So actually this is the protocol feature. So link state updates will be happen. So trigger update. What this guy sent to this guy sent to this guy. So they are not waiting for the 30-second to exchange their route and understand who is there and all. This is just a trigger update. Oh, okay, this guy, I got the new route, you got the new route. Finish. Right? So very fast conversion will happen. Okay, see, let's say let's say India router. So IP interface link. If you see here, right now we have two networks. So let's say we got one more network. So what I'm going to do is I'm going to create one interface. What is called interface loopback. See, loopback is interface. Loopback interface is nothing but a virtual interface. Okay, it is not a sim. See, Giga Ethernet and all. Here, these are the interface where cable will connect it. But virtual interface, it is used for the. It is a logical interface. So what I'm using, I'm creating one loopback. Okay, I'm giving the IP address. Let's say what I'm going to give here is 172.16.20.1 255.255.255.0. So this is subnetted IP address. Okay, I use this one. So this is my IP address. So similarly, what I need to do, I need to add when you create this one. So go and check do show IP router. Do show IP router. So can you see here what it is saying new one? It is saying 192.168.0.24. See slash 24. Actually, this subnet is 172.168.16 is actually class B, but I make it subnetting. I use it slash 24. I just want to use only 256 IP addresses of this particular subnet. So this is the one 24. So what next step? I need to advertise into the OSP, right? So router OSP 1. I need to say network 172.16.20.0 and subnet mask. What is subnet mask? Reverse 0.0.0.255. This is called wildcard mask. Area, let's say 0. Okay, so when I added this guy, can I go to the UK router and check here? Can you see? So IP route, I got one subnetted one subnet 192.168.20.0, and which is who is giving to him? It is coming via 2.1. Who is the 2.1? 2.1 is this guy actually. Okay, and it got the address. See how quickly the network updates. See, in static routing, you remember you need to, if anything, a new network came, you need to go in each and every router and update there. But here, can you see, I added the network here and immediately the network came here. So topology change, you no need to do anything. If topology change, nothing will happen. See, I'm going to just remove it again. No network. Finish. Now just go here in UK router and check. It was here. Now check, see, gone. So this is the beauty of OSPF. OSPF opens shortest path first. Okay, and you can it maintain it is open standard protocol, very fast, and it maintain three tables, IP database table, neighbor table, and the routing table, right? And it give the trigger update whenever any any network down or any network added. It will give a quick update to anyone. See, when we did something here, so we verified here, it means it happened here very fastly, right? So how it happened, it uses the multicast IP address, and the OSPF, we have seen the OSPF neighborship, how the neighborship get formed. We debug this one and we check this one. So these informations are enough. Okay, and the finally our ultimate goal was this one. Can we ping to this guy? Can we ping to this guy? Yes. 30.10. Yes, we can ping 30.10. So how we are going to the tracer? See, if you use this topology only, and you if you do all the OSPF and RIP, EIGRP labs carefully, you know, you will win. You will understand each and everything. Okay, how it is. Instead of going for the big topology, complex topology, just learn here only. Okay. So in the notes, I think I have given you this one also. I have forwarded you the routing notes. So see here, the same uh, static route. What we did 192.168. See, instead of this one, you just need to see the which IP addresses here 1.1, 1.3. So RIP, can you see RIP? You just need to go router RIP, give the network and advertise. Okay, and verify. How to verify? RIP database and RIP route. Similarly, EIGRP, leave the EIGRP, we'll see it tomorrow. OSPF, can you see here? Just say config terminal OSPF and advertise the network plus this is your what is called this is your wildcard mask in the area 0. And how to verify that? Show IP route, show IP OSPF neighbor, show IP OSPF database. Okay, so guys, you have to do this practice today at any cost, so that we will see the EIGRP tomorrow. And you know, after that, RIP OSPF EIGRP. Then tomorrow you will answer me, out of these three, which one is best. Okay, and we will see the comparatively what are the advantages. Then comparatively we will see, and we'll discuss further on this. Okay, so any question for the OSPF? Are you able to do it, the OSPF lab, basic lab? Yes, no.
Yes.
So do it today, and as I told you, just create one base diagram where give all the IP addresses and everything and save it, and later you just need to go and do one lab. Okay, so is clear to know. Okay, so we'll stop here, we'll continue tomorrow. So thank you.
Okay. Thank you.
Oh, no.
Salam.